Imagine having a computer so powerful that it could solve complex problems in seconds that would take a modern supercomputer thousands upon thousands of years to complete. Well, let me tell you this. It's not just science fiction, it's the promise of quantum computing. And today, we're going to deep dive into this revolutionary technology that's set to change this world. Let's get right into it. Alright, so before we get into the actual quantum computing, we gotta talk about how classical computers work. At its core, a classical computer is all about manipulating these things called bits. These are tiny switches that can be either 1 or 0, on or off. Your current computer has billions of these switches, and they're called transistors. See, whenever you're browsing the web, watching a video, or playing a game, your computer is basically flipping on and off these switches or bits super fast. It's like having a billion light switches, and all of our data is stored and processed using different combinations of these on and off states. This system has served us incredibly well, leading to smartphones, the internet, and even artificial intelligence. But unfortunately, there are just some problems that are way too complex for classical computers to solve efficiently. Because I don't know about you, but if I were to, hypothetically, try to decrypt some crazy complex code, I don't want to have to sit around for thousands of years to figure out the secret. Well, enter quantum computing. Here, instead of bits, quantum computers use these cool things called qubits. And this is exactly where things get weird but wonderful. Qubits harness two key principles of quantum mechanics: superposition and entanglement. Now, I know these sound like big scary physics terms, but stick with me. I promise I'm gonna explain it to you, and it's gonna be mind-blowing. Let's start with superposition. Imagine a coin spinning on its edge. While it's spinning, is it either heads or tails? Well, in a way, it's kind of both, and also neither. This strange state of either being both or none, one or the other, is similar to superposition in quantum mechanics. A qubit can be in the state of 0, 1, or both at the same time. It's like our coin is showing heads and tails simultaneously. However, if we were to look at it, it would instantly show either heads or tails. But while it's spinning in superposition, it's kind of in a mix of both of these states. Now, I know what you might be saying. Hey, Einstein, this sounds super useless. Why would I want to know some superposition of both states? Just be decisive. Tell me one or the other. Heads, tails, 1, 0. But let me land the concept. This is actually super powerful. This phenomenon allows quantum computers to process multiple possibilities at once, unlike how traditional classical computers can only process one at a time. To understand the true power of superposition, let's look at some numbers. With only one classical bit, we can only represent two states, 0 or 1. With 2 bits, we can now represent 4 states, 0, 0, 0, 1, 1, 0, or 1, 1. Now, each additional bit we add will double the number of states we can represent. But with these qubits in superposition, the growth is exponential. Here, 1 qubit can represent 2 states at once. 2 qubits can represent 4 states simultaneously. 3 qubits, you guessed it, 8 states at once. By the time you get to 300 qubits, you could represent more states than there are atoms in the observable universe. This is actually mind-blowing. And this is exactly why quantum computers can be so incredibly powerful for certain types of problems. Now that we've covered superposition, let's get into the second key principle: entanglement. Now, my homeboy Einstein once called this spooky action at a distance, and it's just as weird as it sounds. When qubits become entangled, the state of one directly influences the state of another, no matter how far apart they are. It's like having two coins that always land on the same side, even if they're on different sides of the whole planet. This unique connection allows quantum computers to process and transfer information in ways that classical computers just simply can't. Entanglement is a key ingredient for many quantum algorithms, and it's crucial for quantum communication. Let's get into some of the real-world applications of this amazing technology. Like, what can we even do with all this power? Let me tell you that the possibilities are exciting. Number 1, drug discovery. Quantum computers can simulate super complex molecular interactions, therefore ramping up the rate at which we find new medicines compared to current methods. Number 2, climate modeling. Quantum computers can help us create more accurate climate models, helping us to better understand and combat climate change. Number 3, financial modeling. Quantum computing can optimize investment strategies and risk assessment in ways that are impossible for classical computers. See, now you can get your money up and not your funny up. Number 4, as I slightly mentioned before, cryptography. They could break many current encryption methods, but they could also create unbreakable ones. And number 5, our favorite, artificial intelligence. Quantum-based machine learning algorithms could lead to more powerful AI systems. You know that complicated physics homework you gotta do tomorrow that ChatGPT can barely help you with? Well, with quantum computing, things are about to change. Now, these are just a few examples that I wanted to mention, but the full potential of quantum computing is still being discovered and researched. But unfortunately, it's not all smooth sailing. Qubits are incredibly delicate. Even the slightest disturbance, a tiny vibration, a bit of heat, or even interactions with nearby qubits could lead to them losing their quantum properties. This effect is known as decoherence. This process is like trying to balance a pencil on its tip in a room full of fans. Even the slightest breeze could tip it over. That's why current quantum computers need to be kept colder than outer space and isolated from any type of interference. Scientists are actively working to make qubits more stable and to correct errors when they occur. This is one of the biggest challenges in making practical quantum computers. But right now, we're just in the early stages of quantum computing. Companies like IBM, Google, and many research institutions are working on making bigger, more powerful, and more stable quantum systems. We've already seen computers with dozens of qubits, but there are plans for building systems with thousands of qubits in the coming years. In the near future, we might see quantum computers working alongside classical computers to help work on problems that classical computers can't solve on their own. Looking further ahead, we might even see the quantum internet, which will allow ultra-secure communication. Quantum sensors could detect diseases earlier than ever before, and quantum simulations can help us understand the fundamental nature of our universe in ways we can't even imagine yet. Overall, quantum computing is one of the most exciting frontiers in science and technology. It's a field where the rules of our everyday world break down and entirely new possibilities emerge. As we continue developing upon this technology, we're not just trying to make faster computers. We're opening up a whole new way to understanding and interacting with the universe we live in. The quantum revolution is just beginning, and the future is looking very, very interesting. As always, if you enjoyed this explanation, make sure to like the video, subscribe for more amazing physics content, and leave a comment on what interested you and what other videos you'd like to see from me. Till next time.